Hello and welcome back to the course on Python programming. So what are we doing today? Well, what we noticed last time is that we created this scatter plot which answers our question, but at the same time there's something missing about it, something that's not exactly as we want it to be, something that we can improve. And we noticed that the marker size is small, so the markers are very small, you can hardly see them. And today we're going to learn how to improve them. So here I'm going to very quickly add a new line, and just so that we can separate this tutorial. So we're talking about keyword arguments in Python, and it's an advanced tutorial. And you might ask the question, Kirill, why do we have to create a whole tutorial just to change the size of markers? Can't we just specify the correct argument in our code? Couldn't we just do it in the previous tutorial? It'd probably take like a minute to do, if not less. Well, the reason for that is we're going to discuss a conceptual principle in Python that is going to be used not only in visualization and not only with the Seaborn package, but you will also find yourself potentially using it in other situations, and it is quite an important topic that we need to cover off. And that's why it's an advanced tutorial, because it's going to involve some advanced features of Python. So let's, without further ado, let's dive straight into it. What is this advanced feature that you're talking about, Kirill? All right, well, to start off with, let's just make some space. And here we're going to create, we're going to say marker size. That's our comment. And how do we change marker size? Well, let's just go ahead and copy this code from here to start with. Right, so if I run that, that's my visualization there. Now, probably change this a bit to make it a bit smaller, make it an 8. Now, how do I increase the marker size? Well, the marker size needs obviously a parameter. Let's have a look. Can we find that parameter? So let's press Shift Tab. You can see that there's a lot of parameters here. There's hue, there's call, there's row, palette, call wrap, size, and so on. Markers, which markers are being used. So you can change the shape of the marker. Share X, share Y, hue order, col order, row order, legend, legend out, X estimator, X bins, XCI, scatter, fit, reg, CI, and boot, units, order, logistic, lowest, robust, log, X partial, Y partial, truncate, X jitter, Y jitter, scatter KWS, align KWS. Interesting. And at the same time, there doesn't seem to be anything for the color of the markers. There's shape of markers, but no color. So how do we change the color of the markers if there's no parameter here? Well, let's have a look. Let's go down and let's just scroll through these parameters. Let's go to the very bottom and see what the very last parameters are. We've got XY. Actually, the one we need is scatter, align, KWS. So it's basically what this is saying. You can either specify scatter underscore KWS or line underscore KWS. What are these? These are dictionaries. And what do? They are additional keyword arguments to pass to PLT scatter and PLT plot. Very interesting. So to get some more information on this, let's go to the Seaborn description for this specific function. So we'll zoom in here as well. And if I scroll down, you got this, you can see scatter KWS, scatter underscore KWS, and line underscore KWS. What do they do? How can they help us? Let's go down. Let's go down. Basically the same thing. Additional keyword arguments to pass to PLT scatter and PLT plot. What does this mean? Well, what this means is, what's going on is that Seaborn, as we discussed, Seaborn is actually relying on a matplotlib, and it's relying on the, so PLT is a convention for pyplot, right? The one we have in our Jupyter notebook. So here we've also imported pyplot, as you can see, and we imported it as PLT. So what the PLT they're talking about is that same PLT. So the PLT that's in matplotlib. And they're saying that PLT has a function called scatter. So PLT.scatter. And what this is used for, so we're just looking at scatter underscore KWS, is you can pass additional keyword arguments to PLT scatter. And as we discussed, once again, Seaborn relies on matplotlib, on the pyplot package or subpackage from matplotlib. So a lot of these parameters actually are parameters from pyplot. And then it's saying if you need to pass additional parameters, you can do it using these dictionaries. So basically, you can go, this is now the pyplot or matplotlib help. Let's go to the top. I know this might be a bit confusing at first, but it will all make sense just now. So this is matplotlib. This is pyplot. This is the grandfather of everything, including Seaborn. So here it's got lots and lots. This documentation is very long, right? And it'll take you a while to find pyplot scatter. So let's just do it on my screen. Let's scroll down. So, or you can go to this hashtag after the address of this page. So if I zoom in, let's do this again. All right, let's go again. So there is matplotlib.pyplot.scatter. And that is the function that Seaborn lmplt, lmplot, so lmplot from Seaborn is actually a wrapper around matplotlib.pyplot.scatter. So this function in Seaborn is using this function to create its visualization. And now you already have a lot of parameters that you can pass to seaborn.lmplot, but at the same time, there are other parameters in pyplot that are not included in that list. For example, if you scroll down here, you've got S. So scalar or arrow-like shape is optional and so on. So basically, it is the size in points squared, I guess. It doesn't matter. The main point is that S is the parameter for size. As you can see, in lmplot, they didn't include the size as a parameter, but it will still go through if you pass it as this dictionary actually, scatter KWS, it will still be passed on to matplotlib.pyplot.scatter. I know again, this still, like it might make some vague sense, but still it's not ideal. So let's go ahead and practice it, see how it works in practice, and that will make a lot more sense right away. So I'm going to go back to our data frames, and I'm going to go to the bottom. And here, so we're going to just add a parameter. So we've got size equals 8. And now we're going to say, or consistency, let's put this line in here as well. Now we're going to say scatter underscore KWS. And what is it expecting? So this is another example of where we're going to use dictionaries. It's expecting a dictionary. So it's expecting you to pass it something where you'll have the key S and then the value for S. So let's say 200. So basically what you're saying is that, well, let's start with 100. This is a dictionary which has one element in the dictionary. Remember, we talked about dictionaries previously in the course. This dictionary has one element, and instead of that numeration that you have in lists 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, it's actually got a name. Every single element in a dictionary has a name. So this element, which has the value of 100, it has a name of S. So once you pass this dictionary, this object, as this parameter scatter keyword arguments, that's what KWS stands for, keywords. So once you pass scatter as KWS, then on the receiving end, so Seaborn will not even look at what you passed. It will just take that dictionary and forward it on, or it'll unwrap it, but it doesn't really matter. It'll forward on those parameters to matplotlib pyplot scatter, and this function already will analyze what you passed over. So it'll say, okay, S is equal to that. You could pass on additional parameters if you wanted to. So as you know, in a dictionary, you could have a couple of parameters. You could say, and then the next parameter in here, something, 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 equals something, 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 and another one, and so on. But we're only going to pass through one. And so when I do this, you'll see what happens. The size of the markers increases, right? So I'm going to actually increase it even further. I'm going to say 200. Size of the markers increases. I can zoom out to see this lovely chart better. So maybe this is the situation maybe where we want to increase this to 10 as well. So as you can see, this is a much better plot. And I know it's a bit convoluted how this happens. And of course, the Seaborn guys could have thought about that and potentially put that parameter into the plot, but they didn't. Nevertheless, it allowed us to practice keyword arguments and refresh a bit on dictionaries as well. So have a play around with that. That's how we increase the size in lmplot, the size of the markers. Have a play around with that. See what other parameters of lmplot you might be interested in utilizing. But other than that, our visualization for this challenge is ready, and we've already analyzed it. We've already seen that the high income groups are here. the low income group is here, then the upper middle income is closer to the high income, lower middle income is closer to the low income, and you can see kind of a trend that the more internet users you have in a country, the less the birth rate, and other way around, the higher the birth rate, the less internet users you have in the country. Again, correlation doesn't imply causation, but it's just an interesting trend to observe, as we discussed in the previous tutorial. Hope you enjoyed this tutorial of the course and how we got to this visualization. It was a very step-by-step process, but we finally got there, and I look forward to seeing you next time. Until then, happy coding!